Hi, good morning. In this video, we are going to see about my PhD study uh, titled Fabrication and Preclinical Testing of Polyethylene Scaffold containing magnesium oxide and neem for interesting applications. I have did my PhD in UTM, Malaysia. My supervisor was Dr. Ahmed Joram Kutsari. Uh, First, we will see the outline of the thesis. My thesis having five chapters. Chapter 1 shows the background of the study, objective of the study, and scope of study, followed by chapter 2 having literature review, and then chapter 3 having research methodology, and the chapter 4 having residual discussions, and final chapter will be the conclusion and future recommendations and limitations of the study. First, you will see about the background of the research. Uh, According to the statistics, it has been reported more than 40 million people were affected by the chronic wound healing. And the wound healing market was estimated to be around 22 billion at the end of 2025. Uh, the problem statement in my thesis was to treat the wound dressings, the wound dressings were used. Currently in the market, there was 3,000 wound dressings were used. However, they are not still effective for the complete wound healing. Uh, Further, still to date, there is no all-purpose wound dressings. Hence, there is a need for alternative approach for remodeling the damaged tissue, especially for the wound disease. In my thesis, I have used a tissue engineering technique for remodel damaged tissue. Tissue engineering is a multidisciplinary concept which involves three components, mainly scaffold, cell, and growth factors. By combining these components, it was used for the remodeling damaged tissue. Among three components I have stated, the scaffold was main component which carries the cells and growth factors that helps the wound healing. Generally, the scaffolds were generated using many biomaterials through various techniques such as template synthesis, self assembly, freeze drying, melt blowing, and electrospinning. In this research, I have used the electrospinning technique. Electrospinning technique is a common technique used for fabricating nanofibers. In electrospinning, uh, the high voltage was applied to the polymer melt, which converts them into nanofibers. The nanofibers possess high surface to area volume and the porous structurality that helps in the easy wound healing. Then after fabrications, various physiochemical catalysis performed to validate suitability in the wound dressing applications. The objective of my research was to fabricate the PU magnesium neodymium scaffold using electrospinning technique. Then after fabrication, the physiochemical properties are analyzed. After physiochemical properties, the biological properties such as hemocompatibility, cytotoxicity, and cell proliferation performed. And finally, in vivo efficiency is performed to validate the suitability in the wound dressing applications. Uh, in my thesis, there are different types of scopes are available. The first scope is the fabrication of PU magnesium neodymium scaffold using every technique. The next, the various physiochemical can be performed using SIM, FTR, metallurgy, AFM, TGA, and tensile strength. The next, blood compatible analysis performed using APTT, PT, and hemolysis. The next, antibody efficiency performed using agarwal diffusion method. And finally, cell proliferation rates and wound healing efficiency are determined using MTT assay and animal model. The next, the literature review. The literature review was performed into four sections. The first, I used electrospinning technique. In electrospinning technique, it was clearly showed the various parameters are involved, such as polymer concentration, flow rate, applied voltage, under contour distance. These parameters mainly affect the fiber morphology. The next, I have used a polymer scaffold. Especially polymer scaffolds contain lag seed cell proliferation and antibioactivity. Hence, surface modification performed to enhance the biological performance scaffold. Next, I have used MGO scaffold, MGO and neem oil. Both it was clearly evident in the literature. They possess antiviral activity and wound healing efficiency. So I have used magnesium and magnesium oxide neem oil for my research. Literature gap in my research was, as I stated in the previously, the polymer scaffold process disadvantages like lack in antibioactivity and blood compatibility. This research gap motivated us asked me to develop a novel scaffold. So I have used magnesium and neem oil in PU matrix as a validate as a alternative component for the interesting applications. In the next video, we will discuss in detail about the fabrication and the various characteristic techniques performed to validate suitability in the interesting applications. Thank you.